Hi, everyone. There we go. I'll play. So as I heard you all talking, I kind of did some last-minute changes because I was told one thing, and then just like a teaching, you hit this flip on the fly. So it's not about K to 12, since a lot of you are not going to be probably into the K to intermediate, but maybe high school and teaching some of your university colleagues that are going to have no idea how to teach or how to code or how to work through things. So we're going to be doing an introduction into CS first, as well as code.org. But before we begin, as introduced, my name is Jonathan. I'm an actual grade 4 teacher in the Peel District School Board, and I work for EdTech team as well. You can follow me on Twitter and all that stuff if you really want to. And these are my lovely kids and my lovely wife, and inspiration to pretty much everything I do when it comes to coding, when it comes to working with children, and when it comes to teaching in general. Izzy's 9. Micah just turned 5 a little while ago, and my little boy is turning 3 in a couple more weeks. So if you do want to get more into teaching and learning more pedagogy, EdTech Team Canada is a great place to kind of look for it. They do a lot of good workshops throughout all of Canada. Here in Ontario, there's a couple of workshops and stuff like that. If you need to have them as partners, they're a great place to look for it as well. So you can contact them through edtechteam.com/Canada. There is a US one as well, so you can easily go with that too. So today, being a teacher, I do set learning goals for us to think about. So by the end of this hour-ish that I have with you, I want us to have a better understanding of how to teach students. How do we introduce coding into them, especially those who have no idea what to do? What are some strategies that we can use for? I want you to have a better grasp of what CS First is and how to leverage the program to kind of help you with STEM and with coding concepts to students. And of course, answer any questions that you may have about teaching that I can do in 1 hour that I have learned over the last 17 years of teaching. So we'll see how that goes. So to get us started, I don't like to talk all the time. So I want you to actually get up and do some stuff. So I have some paper. We're going to go low level here. And I would like you to pick a spot in the room, like mentally. And I would like you to write directions to get to that spot. Then give your directions to a friend or someone next to you and have them find it. I will leave you as far as what directions. You can pass that down. What directions you want to give out to them. Hopefully that's enough for everyone. So just mentally pick a spot anywhere in the room that you want to bring your friend to. Write down how you want to get there, how many steps to get there, and see if your friend can actually follow those instructions. Okay, so partly it was me to get you up and moving. I hate sitting. Partly also to kind of show you how I introduce coding to kindergarten students. This activity I actually call Code a Friend or Find a Robot or do whatever. And so my kindergarten students actually use direction and tape, and they just step it by it, and the kids actually follow. So these are 4-year-olds and 5-year-olds following coding directions. This is a great way to introduce those who are like petrified of what coding is, because ultimately, it's a set of instructions. It's a procedural language. Obviously, you know way more than I do. I am a grade 4 teacher. I am not a programmer. I just knew the benefit of coding and how much the world needs it and how much my students needed it. So I decided to learn how to draw a square in Scratch. And that's where my world started. So this is a great way to introduce that. I have no premise of, just letting you know, I'm not a programmer. But it was just getting you used to things. Now, however, teaching is what I'm very good at. And teaching I cannot do in an hour. I can't tell you everything there is to it. But if you are planning things and you are trying to plan how to teach coding, there are some things that you want to think about. This is a great book. They have it for pretty much every subject. It's the same model all the way through. And it's one of the fundamental things that I follow in my pedagogy of teaching. It is by Mary Stein, Jennifer Carter, Margaret Smith, and Daniel Ross. And the idea is there's 5 things that you want to think about as you are teaching or planning in general for anything. The first thing is you need to anticipate. This is probably the most fundamental thing that all teachers struggle with, because in general, we assume too many things, and we don't anticipate what problems could occur, what things may happen. Honestly, be prepared for almost anything that happens, especially when working with high school and working with younger students. The possibilities are pretty endless. You're not supposed to see everything, but if you can find most things, you are better able to handle when those problems arise. The next thing is that you're constantly monitoring. As a teacher, I don't sit down. As you can tell, my ADD kicks in eventually anyways, so it doesn't really matter. But the idea is that you are looking at how kids are working or how students are working or your colleagues are working, and because you've anticipated all these problems, you're like, oh yeah, I know what's going to happen. I'll show you one eventually. In Scratch, kids lose their pixie. Like, it goes off the wall, and they're just like, where'd it go? I'm like, don't worry, it's there. It's just on the Cartesian plane that's way down in negative like 200 and negative 500, and you're in positive space. And they're like, oh. I'm like, so then you have to I teach all my kids to create a reset button that just sends their Scratch their pixie back to the start of where they want to see it on the page. And they're like, oh, that makes so much sense. But that took me like a year to realize to build that. One of my students constantly said, I don't know where it is. I'm like, I don't know where it is either. So when you're monitoring, you're looking for all those things, but you're also looking for your end goal and your end results. You're thinking about that learning goal. You're thinking about what I wanted to accomplish, because while you're monitoring, you're also selecting and you're also thinking about how I can consolidate or connect all of this back together. Whose projects do I want to showcase right now? Who needs confidence building, maybe? Who needs to present certain things at a certain time? This is all part of how you build those skills into students who have no idea what the heck they're doing, or in skills in general, and teaching in general. And the final piece, that 5th piece, is that connecting piece. No matter what you have, leave time to consolidate the knowledge. If you don't consolidate the knowledge, anyone who leaves your workshop kind of doesn't really understand what the heck they've been there for. Like, why am I here? And then they walk away, and then they may come back and be like, I don't know if I want to return to your workshops anymore. I don't know if I want to try this again, because I didn't really learn anything. So you want to make sure that they've connected to something, your one learning goal back again, and take a look through that. So to help you out, I've developed a little planner. It's just a graphic organizer. It's really a Google Doc. And the slide deck that is given to you, there is you can actually click on the image and it'll bring it up for you. I also have a paper copy too, so you can take it home with you if you want. But the idea for you is really, when you're planning these workshops or you're planning to teach coding through students, this is how I do it. Literally every lesson, even after 17 years of teaching, I still literally plan out every single lesson I want to have for my students. And the main part is really in that, what are some of the possible problems that could occur? And I probably should have added, how am I going to deal with them? It's great that you think about the problems, but what are you going to do to actually solve them when they occur, to help you out? So, introducing coding. Give them something that they feel comfortable doing. For me, most teachers, when I teach teaching, I have a basic introduction to coding that says, do you think you want to code? And the very first thing I tell them to do is draw a square in Scratch, or draw a triangle. And they're like, I can't do that. I'm like, yep, you can. Like, that's where I started. But something comfortable, something easy, something for them to be like, yes, I did it. And it'll help them out. And then, of course, you can move on from there. And I know you might think that's basic, but it's something to think about. Also, show them the tools. You're going to have to be very explicit with the tools that you're giving them. Whether it is Scratch-based programs, it's CS First, which is Scratch-based. You're using code.org. Maybe you're bringing out some robots, or you're bringing out microbits, or you're bringing out microcontrollers, or you're doing machine learning, or you're doing JavaScripts. For some of your beginners who never, or whatever language that we end up writing in, some people may not know it. You got to show them how to do certain things at a very slow, methodical pace. To a point where sometimes in your brain, you're like, come on, why don't you get this? Like, I've shown people how to drag move 10 spaces like millions of times, and I still have people that say, I don't know where the move block is. And I'm like, oh, okay, that's fine. But you have to understand that for many people, this is the very first time that they've seen it, and so you just say, here it is, and you patiently work through it. Give them time to explore. They have to make mistakes. As much as it's uncomfortable to make mistakes, they have to learn to make mistakes. And you know that with your own thing and your own learning, especially like when you're trying to learn something brand new. As much as someone giving you information is helpful, the best thing you can do is get in there, make the mistake, and be like, okay, I don't know what I did wrong. I did this, and then someone's like, oh, you forgot this. And you're like, oh, yeah. And you learn so much more. But if you don't build in that exploring time, all you're doing is, like the Charlie Brown, I might be dating myself here, I'm sorry, but the Charlie Brown teacher, wah, 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 wah. And that's all Charlie Brown hears. So you want to have that, as much as I'm talking to you right now. And the last thing is, once they've learned or they've started to master some of these skills, give them a task that's important to them. If you just give them a random task, they may do it, but the most thing is that they have to connect to it. And a lot of you have talked about that in your presentations about like thinking about a social issue that they might want to conquer. Maybe it's a passion project that they really want to look for. Maybe it's something about the university that you want to solve. This is something that's meaningful, and they're going to buy into it a little bit more. They're going to research it more. They're going to want to learn more about it, and they're going to want to ask help for it. So some common issues that I find when starting out. Now I'm talking about block-based coding. When using Scratch, and I'll show you Scratch, and I'll show you CS first. I just want to get all this information out. They often forget that there's a start command to anything. They make all this code, and all the kids go, it doesn't work. I'm like, yeah, because you didn't put the when press the green button, then start. And they're like, oh. And so then they forget that. They lose their pixie, which is when you see, how many of you have ever used Scratch? Awesome. So like you have that small little box, but there's technically still space down here, and so then the pixie goes away. Many people give up. Like they're 10 minutes into it, and they're like, I don't want to do this anymore, I'm done. Even adults, even kids, like, I'm just done. And then you will have different abilities, so you're going to have to plan for that as well. You're going to have people who are like, yeah, I got it, I'm 5 minutes in and I'm done. And you're going to have the other one who's like, still like wondering how to log into Scratch. and giving you that blank stare. So you're going to have to balance that, and that's where the planning comes in. Being able to be like, okay, I'm giving you time to explore so that those who can do things independently are doing it independently, and those who can't, I'm going to work with you. It's a very hard skill to learn, something I'm still practicing, but it's part of teaching in general that works well. So working with students, working with anyone really, they just want to have fun, first and foremost. I always say if my kids ask to go to the bathroom a lot, they probably don't like what you're doing. But that's young kids. Adults are more patient. They just, or they just walk out. But most importantly, relationships matter. I can't stress this enough for any club that you start, for anything that you do in your life. This is beyond coding. The relationships that you build with people matter the most. When you can relate to them, when you can have fun with them, you can give them feedback. You can bring them back. This goes for your job interviews. This goes for life in general. If you're trying to bring people into your business or trying to bring people into your club, relationships are the most important thing you can do. The next thing is plan for the worst. If you can't be flexible in your thinking, even like today, I had to switch things up literally as I came here, and that's okay. Life happens. Always have more than you think, especially in a workshop. You may, there's millions of times where I've gone into kindergarten classes thinking that this would take like the whole day, if not the whole week, and they do it in 10 seconds. And you're like, okay, now what do I do? Imagine that with 5-year-olds, and you still have 30 minutes to plan with them. So that's something to have. And then always have a backup plan for anything that you're thinking about. And then remember that thinking does take time. And thinking for different people takes time for different people. And so you have to be able to plan for all that. OK, so what is CS First? I'm hoping this video works, because they explain it much better than I can. Oh, my sound. That's weird. OK, my sound only works on my computer, not through the HDMI. You'll play the video? Full screen?
Dre and Tim here with another EDU in 90. Many of you requested episodes on computer science programs, so in the upcoming months we'll be featuring Google programs that can help bring you coding into the classroom.
And to start, we'll focus on CS First, a program that teaches kids the fundamentals of coding. And one of the best parts about the program is that it requires no prior experience coding for teachers or students.
Google CS First is a free computer science curriculum geared for students ages 9 to 14. The program uses themes like music, art, and sports to show students that coding can be a way to explore their many passions.
That's right. The CS First program highlights the role that coding plays across a diverse set of industries so that students can understand that it's a skill that can be used in ways that they may not have initially imagined. With CS First, students use a programming language called Scratch to build their own animated stories. In Scratch, students code using blocks that snap together like puzzle pieces. For example, in the Code Your Own Google logo activity, students design their own version of Google's logo by drawing and editing letters, adding animation, and more. Teachers and volunteers do not need to be familiar with coding in order to guide students through the CS First activities. Each activity and theme comes with tutorial videos to help students understand the basics of computer science.
In addition to instructional videos, the program provides lesson plans, solution sheets, and other resources so that anyone with a passion for helping students explore and create has the tools they need to lead a CS First club. When you sign up to start a CS First club, you can download and print the materials in English, French, German, and Italian. In some countries, you can even receive a free kit of printed materials, including stickers and passports for your students.
To learn more about bringing CS First to your school, check out the program website at g.co/csfirst. There you can sign into a personalized dashboard and access the full curriculum and tons of digital resources.
That's a wrap on today's episode. Make sure you subscribe to our education channel and check us out next time for another EDU in 90. See ya!
Unfortunately, Canada isn't one of those places where you can send those free lesson plans to yourself. I found that out today. I tried to send it to myself. Didn't work. Maybe Google can get on that one. So this is the CS First platform. So when you sign in, I've signed in as a teacher. You would probably sign in as a teacher. It doesn't really ask you for, to prove that you're a teacher. You just sign in. You can create your own classes, which may not be as helpful for some of your university ones. But if you're definitely working with a high school group, this might be something that you want to create like a club page that they can all go to, because when kids log in, you have more control over, you can see whose progress is doing what with it. Unfortunately, I only started school 2 weeks ago, so I don't have my kids in there yet. And yes, I teach in a balanced calendar, so I teach all year round. It's kind of cool. What you probably want to look at is the curriculum side of things. So inside the curriculum, there's very specific subject areas that you can go through. There's the hour of code, which is kind of like just cool activities. Or you can go into the multi-day type of things that work for introductory lessons or more advanced learning. So let's go into storytelling. I have added this to the class, so it's weird. But the idea is that it gives you literally the anyone can follow it along. So the very first thing that you're going to see is the CS first survey. It's up to you if you want to do that. But when they play the videos, it's literally a video about how to introduce certain things and what to do. I'm not going to play the video, but you can see what's, and then the kids just move to the next. And it's literally videos upon videos of teaching kids the concepts that they need to learn and how to go through it. So they're going to have 2 windows open. They're going to have the video window opened up and their Scratch. And they go through that. And so you know Scratch. This is in 3.0, which is even better than the one that they showed in the video. So what I had planned for you to do, speaking of exploring time and sharing time, I would like you to team up with people if you want to, or you can work by yourself. You are going to go into CS first. You are going to pick an activity that you would like to do, but you are going to be thinking of it as a teacher's point of view. So I have the planner if you want to. I don't know if the links were given to you, so at least I have the planner. I would like you to think about, don't worry about curriculum too much. You can look up curriculum if you want to, but think more about your learning goals that you want to. Lesson description. What problems do you think could occur with that lesson? And then play around with it. I think there's 20 here that I photocopied, but I could be wrong. Okay. So just like I said at the beginning of our planning, give time to explore, which I did. Now, just to consolidate some things and thinking about, would anyone, I guess maybe I can use the mic too. I wasn't going to, but I found that this is a microphone. Would anyone like to share maybe something that you learned or something that you still have a question about, or something that was like, ooh, aha, moment with what you just did with your planning? Well,
I think just the technical difficulties you run into when you don't try to break things. Like for us right now, we realized if you shrink your window to less than 50%, some of the buttons disappear from the entire window. And so it's like, we were just lost for a good 5 minutes looking for this button because it's literally not there anymore until we expanded the window. That's just things like intentionally trying to break your lesson so that you know what issues people run into.
Yeah, and that's what I mean when I say anticipate. When I say anticipate, it's about those things that could physically go wrong with space, with the kids themselves, but also with the program that you're trying to build. It's great aha. Anyone else have something they took away or learned?
We were talking about like if someone gets like frustrated or is like really stuck on something, how to like help them and the best way to talk to them, and instead of just giving them the solution, kind of being like, hey, like what do you want to do? Ask them questions about it, and then relate that back to the tool so they can kind of help themselves and like kind of calm them back down so they're not getting really upset.
Yeah, giving up is a big part of those new beginners, no matter what age they're in. One thing that being able to anticipate those problems, you can probably see where they're going to be frustrated at. So like shrinking your screen and going, where the heck is this button? I've been looking at it for 10 minutes. And you're like, oh, just open it up. And they're like, oh, there it is. And it's there. Or sometimes it's just a matter of, okay, where are you? Where are you stuck? What have you tried? And then you can work backwards from it. Another one that happens in Scratch a lot of times is that they've connected it, but sometimes there's something wrong with the logic in the sequence of their block code. So I have to like take apart block by block until it works and test everything. And then I'm like, okay, this worked to this point. Now where do you go? So just working with them and just staying as calm as you can helps too.
We ran into a rather peculiar problem. So we added a backdrop, right? And we added code so that when you click the sprite, you change the backdrop. And then we went back to, say, the code section, and the code wasn't there anymore. But the code still worked. So like when I click on it, it still changes the backdrop, but there's no code. So yeah, I don't know what's up with that. I guess that was a technical issue that we faced.
So that's something that kids get into some fun. so you have your costumes, you have and then you have backdrops, and then you have sprites. So each of them are codable. So right now my backdrop is on, so when I drag this code into my backdrop, I'm in backdrop coding. If you notice it changed, so now it says backdrops. When I changed here, it says costumes. They have to be on the right. That's why your code still worked, because it's part of the backdrop, not part of the sprite. So going back and forth, but that is something that often happens. They're like, where'd it go? And you're like, click. Oh. I also find the very first thing I teach them to do is to create that reset button of everything. Just put everything back to normal. When you hit this button, reset. And they're like, awesome, that works. Okay, one more, and then we'll move on to something else, and then we'll have more questions and answers later. But
another thing we notice is like setting realistic expectations. Your final product won't look like the final product in the video.
yes.
We were doing like the draw letter tutorial, and the one that they drew was super neat and like smooth. I tried drawing my own letter, and it was just like this wobbly, shaky mess. Because drawing with a trackpad is just not something I do.
Yeah.
And to make sure like their students know that, hey, just because you're following this step by step doesn't mean it'll look the same at the end.
Yeah. So realistic expectations, period. So like that's why I say to plan, and that's what the five practices help you with. If you don't have those expectations, those learning goals that you want to achieve, it's hard to consolidate everything in the end. And even then, when you've planned a learning expectation, it doesn't necessarily mean that that's what ends up happening. Oh, I have 5 minutes overall. Wow. Okay, so here's code.org. I guess time got past me, sorry. So besides CS First, there is code.org. It's another great places to look for, especially with beyond K-12, where you're trying to teach some of the students into some of the other programs that are available. Online courses, university courses, learning how to JavaScript, which I'm now going to try to learn how to do that. That's my goal this year. I don't know if it's any good to learn how to do it yet, but I'm still going to learn. It's very helpful to work through. If you are ever working in a K-10 situation, I have created some things to work through with choice boards, and I brought some of my robots, but we ran out of time. Hence, always have something to back you up. And a good friend of mine, Brian Aspinall, he's really big into computer science and pushing computer science into the schools. If you check his website out, he has tons of other tutorials and learning for Python, for Java, for microbits and CS First, and a whole bunch of other stuff that go through it. So 5 minutes left. Thank you. But before we end, is there any questions? And you can also reach me anytime you want for anything. Email me, so.jonathan1@gmail.com. Tweet me, DM me. My teaching resource links are there at bit.ly/M Mr. So, S, resources. I know it kind of looks like Mr. Soar sources, but